Let's recap what you have learned at O-level. At O-level, you learn about electrolysis and electric cell. And you learn about the fact that reduction occurs at the cathode, oxidation occurs at the anode, and the cathode always attracts the cation, and anode always attracts the anion. So the two acronyms that one needs to remember is RCOA and CCAA. We'll now illustrate using the electrolysis and the electric cell setup to prove that all these rules continue to be applicable to them. At A-level, an electrolysis setup is also termed as an electrolytic cell, where there's a need for an external current to drive the electrolysis, which means you need to be connected to a battery. In the case of the electric cell, it is called the electrochemical cell. So in the electrochemical cell, does not need to be connected to a battery because it itself is the battery. Electrolytic cell. In electrolytic cell, the conventional current flow is from the positive terminal of the battery, and the current will end up in the negative terminal of the battery. Based on that, the electron flow will flow out from the negative terminal and into the electrode. The electrode will be negatively charged, as it will be flushed with electrons. And since it's negatively charged, it will be attracting the cation. Hence, the electrode can be termed as the cathode, because cathode attracts cation. Alternatively, we could also say that since the cation that's attracted to this electrode is going to take in or gain electrons, so reduction will have occurred. And since reduction have occurred using the acronym RC, we will know that reduction occurs at the cathode. We will also arrive at the conclusion that the electrode is a cathode. The electrode that's connected to the positive terminal will have the electrons flowing out of the electrode. So in this case, the electrode will be short of electron and therefore positively charged. Since it's positively charged, it will attract the negatively charged ion, which are the anions. So anode attracts anion, therefore we can conclude to say the electrode is an anode. Alternatively, we can look at the electron flow. Given that the electron will be lost by the electrode to the positive terminal of the battery, we can conclude that oxidation has occurred, and using RCOA, where oxidation occurs at the anode, we also arrive at the conclusion that the electrode is an anode. And one example to look at would be that if we will have to have copper 2 sulfate as the electrolyte, and both the electrodes are copper, then if you recap back in O-level, we can conclude that at the anode, the copper would actually oxidize to give 2 electrons. While in the case at the cathode, the Cu2 plus cation will gain the electron to deposit copper on the electrode. Hence, in the equation, it's clear that oxidation takes place at the anode as copper's oxidation state change from 0 to +2, while reduction takes place at the cathode when the oxidation state of Cu2 plus drops from +2 to 0. Electrolytic cell, we have zinc and copper connected in this case to a bulb. Let's make the electrolyte aqueous copper 2 sulfate solution again. And given that zinc is more reactive than copper, zinc will oxidize. So zinc will oxidize to give Zn2 plus 2E. Which means, in other words, the electrodes will be moving out from zinc and going into copper. Given that zinc undertakes oxidation, using RCOA, we'll know that oxidation occurs at the anode. So therefore, the electrode here is an anode. At the other electrodes, since electron is being gained by the copper electrode, reduction would have taken place. Using again RCOA, we will know that reduction occurs at the cathode. So which means this will be the cathode. And if the electrons actually congregate at the copper electrode, we will know that it will actually attract the cation. And the Cu2 plus would actually be, the Cu2 plus will undertake reduction at the cathode to give you your copper. So we could also conclude to say that when the cation is attracted to the electrons, where we can use CCAA to conclude that the cathode attracts cation, and that also allows us to confirm that this electrode is a cathode. Finally, in conclusion, let us take a look at each of the electrode and decide whether they are positive or negative. In the case of electrolytic cell, the cathode is flush with electrons, since the electron will flow from the negative terminal to the cathode. At 4, the electrolytic cell is negative. While for the anode, since the electron departs, the anode will become positive. In the case of the electrochemical cell, bear in mind that the setup is actually the battery. So if you were to put a battery to represent it, this will be the polarity of the battery, where the electrons is flowing out from the negative end and flowing back into the positive end. So therefore, because of this, we will conclude to say that zinc is the negative terminal, while in the case of the cathode, it is the positive terminal. So it's important to note that the anode of an electrochemical cell or an electric cell is the negative terminal, and the cathode is the positive terminal. In electrolytic cell, it's the opposite. The cathode is the negative electrode, while the anode is the positive electrode.